Hi guys, my name is Edgar Viernes and we are Group 6 together with Lemuel, Cacatian, Jerwin, Tagle, Rioscen, Viadan, Cedrick, Caceres, and me. We will talk about water. In this video, we will tackle about the importance of water, the compositions, properties, and some of the processes related to water.
Have you ever wondered where your water comes from? Before it hits the drinking fountain, a faucet, or your refrigerator? About 70% of the earth is covered by water.
Water. Our basic concept of water is like the most common water that we encounter every day, like drinking water, water for taking showers, and water for washing clothes and dishwashers. Or we may have an idea about natural large bodies of water, like rivers and oceans. But did you know that there's more to water that we should understand so that we can use water more efficiently? And that is what water chemistry is all about. Water chemistry. It is a science that is focused on understanding the chemical processes that affects the natural composition of water and its suitability for human uses. This includes the studies of the water's chemical composition and its properties. This also includes the analysis of chemical constituents present in water, such as the minerals, gases, compounds, and even contaminants. Let us define first what is water. Water is a clear, odorless, tasteless, and almost colorless liquid that freezes when the temperature is 0 degrees centigrades or below and boils at the 100 degrees centigrades and up. Water plays a big role in chemistry. Its ability to dissolve a variety of molecules has earned it the name universal solvent. So this ability of water allows other cells to transport and use substances like oxygen and nutrients. Water exists in three different forms, which is liquid, solid, and gas, that will be discussed later on. We all know that the chemical structure of water is H2O. Not because of this guy, but because water is the most famous compound in chemistry, naming it the universal solvent, right? Dihydrogen monoxide or H2O has two atoms of hydrogen and one atom of oxygen. The molecular bond of water is called polar covalent bond. What does it mean? It means that the other side or the other pole of the compound is positively charged, which is on the side of hydrogen, and the other pole is negatively charged, which is the side of oxygen. This characteristic of water allows it to combine and react with other compounds. That is why water becomes a very good solvent. Aside from the role of water in chemistry, water is also extremely important for us humans. It is because large portion of our body requires water so that chemical processes in our body can operate, such as digestion, lubricating our joints, protecting other sensitive tissues, getting rid of wastes in our body through urination or perspiration or sweating. Even while thinking, water is required since about 90% of our brain is composed of water. Water is also essential for plants so that they can generate their nourishment through photosynthesis process. Let's now move on to the types of water. There are four main types of water: groundwater, surface water, wastewater, and stormwater. Groundwater refers to the water that is present beneath the Earth's surface. It is the water that fills the pores and cracks in the soil or in the rocks. Groundwater makes up almost 22% of the water that we use. It uses in agricultural, municipal, and industrial processes. Next is surface water. Surface water is the water that is present on the surface of the earth. For example, the rivers, lakes, oceans, and glaciers, and many more. Because of the easy access to these bodies of waters, it provides about 78% of the fresh water used by us. Next is wastewater. Wastewater are the waters that has been used in home or in residential areas. Water that comes from ordinary living processes like bathing, toilet flushing, dishwashing, or laundry. These are all considered as wastewater. Lastly is the stormwater. Stormwater are the water that came from precipitation or from the rainfall or from the melting of ice and snow. This water will soak into the ground or into the exposed soils in the environment and saturate it, or just stays into the solid ground, or for example pavements and concretes. And these waters will eventually evaporate back again to the atmosphere and undergo water cycle once again, or will just flow as a runoff in our drainage systems and downpipes. That is all for my report. Thank you for listening.
Hello everyone, my name is Lemuel a Cacatian and I will discuss about chemical composition of water. Water, a substance composed of the chemical elements hydrogen and oxygen and existing in gaseous, liquid, and solid states. It is one of the most plentiful and essential of compounds. A tasteless and odorless liquid at room temperatures, it has the important ability to dissolve of many other substances. Indeed, the versatility of water as a solvent is essential to living organisms. Example of importance to study of water composition. Distilled water versus purified water. Distilled water is a type of purified water that has had both contaminants and minerals removed. Purified water has had chemical and contaminants removed, but it may still contain minerals. Chemical bonding of water with other elements. Combination of carbon dioxide and water is to form carbonic acid. Example of carbonic acid is wine and drinks. Combination of sulfur trioxide and water is to form sulfuric acid. Example of sulfuric acid is fertilizer, pigments, drugs, explosive, detergents, and inorganic salt and acid. Methane hydrates is formed when water and methane gas combine of temperature below 10 degrees Celsius and pressure greater than 30 bar or 30 times normal atmospheric pressure. Methane hydrates form in places that are gaseous, wet, cold, and under pressure. Water packs. Water is called the universal solvent because it dissolves more substances than any other liquid. This means that wherever water goes, either through the ground or through our bodies, it takes along valuable chemicals, minerals, and nutrients. Pure water has a neutral pH of 7, which is neither acidic less than 7 nor basic greater than 7. The water molecule is a highly cohesive. It is very sticky, meaning water molecules stick to each other. Water is the most cohesive among the non-metallic liquids. Water molecules are also adhesive in that they stick to other surfaces. Both cohesion and adhesion make water molecules very sticky. Pure water, which you won't ever find in the natural environment, does not conduct electricity. Water becomes a conductor once it starts dissolving substances around it. Water has a high heat index. It absorbs a lot of heat before it begins to get hot. This is why water is valuable to industries and your car radiator as a coolant. The high heat index of water also helps regulate the rate at which air changes temperature, which is why the temperature change between seasons is gradual rather than sudden, especially near the oceans.
Hi guys, my name is Edgar Viernes, and for my part we will talk about the importance of water in different fields, purifications of water, and lastly, water cycle. Importance of water in different fields. We have human life. It delivers oxygen. Water is essential for carrying oxygen from our lungs to the various regions of the body. Because blood is 90% water. This is significant since oxygen is required for the majority of bodily processes. Regulates temperature. One of our body's fundamental processes, homeostasis, is frequently hampered by a lack of water. The impact on how we control body temperature is one of the most important effects in our body. Lubricates the joints. Cartilage contains 80% water. It is essential since connective tissues allow joints to move in fluid motion and cushions bones against impact. Second reason why water is important is because of how it supports ecosystem. Water's primary purpose include promoting plant growth, providing permanent homes for species that call it home, serving as temporary residence or breeding ground for numerous amphibians, insects, and other waterborne organisms, and supplying the nutrients and minerals required to support physical life. Engineering purposes. Applications of water resources. Engineering that use water for advantageous reasons include irrigation, navigation, hydroelectric power, production, and water supply.
Water on Earth is constantly being heated and cooled. As it does, it moves in a cycle between the surface of the Earth and the atmosphere. This process is called the water cycle. On Earth, water can be found in the ocean, lakes, rivers, and streams. The heat from the sun warms the water on Earth. When the water warms, it changes from water into a gas called water vapor. This process of changing from a liquid to a gas is called evaporation. The water vapor in the air cools as it rises and changes to liquid water in the form of tiny water droplets in clouds. This process of changing from a gas to a liquid is called condensation. The water droplets get bigger as they combine with other water droplets. They eventually fall back to the surface of the Earth as precipitation. Precipitation includes rain, snow, hail, or sleet. This pattern of evaporation, condensation, and precipitation repeats over and over. Uh-oh, it looks like it's about to rain. I better get my umbrella. Gotta run. Bye!
Water cycle. The water cycle shows the continuous movement of water within the earth and atmosphere. We have 7 processes of water cycle. We have evaporation, condensation, precipitation, interception, infiltration, percolation, and transpiration. Condensation, the process by which water vapor in the air is changed into liquid water. Precipitation, any water that condenses into liquid or ice in the atmosphere and falls to the ground. Interception, the process of precipitation that the Earth's surface intercepts and then evaporates. Infiltration, the physical process of infiltration involves the passage of water through the region at the soil-atmosphere interface. Percolation, percolation is the movement of water through the soil itself. Transpiration, the transfer of water through plants from the soil to the atmosphere. Plants breathe through their leaves as they absorb liquid water from the soil and exhale water vapor into the atmosphere. What is water purification? It is a process by which undesired chemical compounds, organic or inorganic materials, and biological contaminants are removed from water. The purification of water. We have 5 processes: screening, coagulation, sedimentation, filtration, and disinfection. We have the first process, which is screening. Removes objects such as rags, papers, plastics, and metals to prevent damage and clogging. Second process, coagulation. By adjusting the electrostatic charges of particles suspended in water, the chemical water treatment procedure removes solids from water. Third process, sedimentation. The process of allowing particles in suspension in water to settle out of the suspension under the effect of gravity. Filtration, the process in which solid particles in a liquid or gaseous fluid are removed using a filter medium that permits the fluid to pass through but retains the solid particles. And the last part of the process is disinfection. Water treatment facilities may add 1 or more chemical disinfectants. It includes chlorine, chloramine, or chlorine dioxide after the water has been filtered to eliminate any lingering parasites, bacteria, or viruses.
Hi guys, I'm Rioscen and now I will discuss the properties of water. Water has 14 major properties, and that is surface tension, cohesion and adhesion, polarity, density, specific heat capacity, viscosity, capillary action, boiling point, heat of vaporization, solubility, electronegativity, thermal conductivity, and electricity. First property we will discuss is surface tension. Surface tension is the property of a surface of a liquid to resist an external force, commonly on things that has less density than water, like a razor blade or an insect. Next is cohesion and adhesion. Cohesion and adhesion are 2 properties of water that describe how water molecules interact with each other. Cohesion means that water likes to stick to itself, and adhesion means that water likes to stick to other things. Next is water polarity. Although the net charge of a water molecule is 0, water is polar because of its shape. The hydrogen ends of the molecules are positive and the oxygen end is negative. This causes water molecules to attract each other and other polar molecules. Now, density. The water density of measurement is 1 gram per milliliter or 1 gram per cubic centimeter. Actually, the exact density of water is not really 1 gram per milliliter, but rather a bit less at 0.99 gram per milliliter. Next is specific heat capacity. One of water's most significant properties is that it takes a lot of energy to heat it. Precisely, water has to absorb 4,184 joules of heat for the temperature of 1 kilogram of water to increase 1 degree Celsius. Viscosity. Viscosity of water at a temperature of 20 degrees Celsius is approximately 0.01 poise. Viscosity is a measure of the resistance of a fluid to deformation at a given rate. For liquids such as water, viscosity can be perceived as a measure of the liquid's resistance to flow. Capillary action. Capillary action is important for moving water around. It is defined as the movement of water within the spaces of a porous material due to the forces of adhesion, cohesion, and surface tension. Boiling point of water. It seems like one of those basic science facts is water boils at 212 degrees Fahrenheit or 100 degrees Celsius, right? Well, not always. It still depends on where you're doing the boiling. In fact, water boil at about 202 degrees in Denver, USA, due to the lower air pressure at such high elevation. Heat of vaporization. Heat vaporization of water, that is, water has a high heat of vaporization, the amount of energy needed to change 1 gram of a liquid substance to a gas at a constant temperature. Water's heat of vaporization is around 540 calories per gram at 100 degrees Celsius, or also water's boiling point. Solubility. Water solubility is a measure of the amount of chemical substance that can dissolve in water at a specific temperature. The unit of solubility is generally in milligram per liter or parts per million. Electronegativity. Water has an electronegativity value of 1.5. To determine this value, know the bonds formed between atoms. Water is made up of 2 hydrogen and an oxygen bond. The electronegativity of hydrogen is 2.0 and the electronegativity of oxygen is 3.5. Thermal conductivity. Thermal conductivity can be defined as the rate at which heat is transferred by conduction through a unit cross-section area of a material. And also, water is also one of the highest thermal conductivity of any liquid. The heat conductivity of water is high because ions are unscrewed due to the increase in temperature. Therefore, the conduction also increases. So you may wonder, if the thermal conductivity of a water is one of the highest, why does the water absorb enormous energy to heat it up? Well, it is because water also has high heat capacity. Although it can conduct heat pretty quickly, it can also handle more heat energy than any liquid. And lastly, electricity. Pure water is a strong dielectric medium, meaning that long-range electrostatic forces acting between two charges in water are dramatically reduced. Our next topic is about states of water. Water has 3 states: solid, liquid, and gas. Under standard condition for temperature and pressure, water exists in the liquid state in the temperature range of 0 to 100 degrees Celsius. Liquid waters cover 70% of the Earth's surface. But did you know that only 1.2% of that is drinkable and 30% of that 1.2 is inside the Arctic and Antarctic ice? And ice is the solid state of water, a normally liquid substance that freezes to the solid state at temperature of 0 degrees Celsius. And lastly, the gaseous state of atmospheric water is termed water vapor, or simply vapor. It is usually formed on our atmosphere because our atmosphere has low pressure and cold temperature. This topic is about water transformation. Water transformation. The changes of state include melting, sublimation, evaporation, freezing, condensation, and deposition. All changes of state involve the transfer of energy. The water particles in each state behave as energy is absorbed or released. Melting. Changes in temperature cause water to change state. Pure water transition between solid and liquid state at 0 degrees Celsius at sea level. This temperature is referred to as the melting point. When rising temperature are causing ice to melt and change state from solid to a liquid. Sublimation. For those of us interested in the water cycle, sublimation is most often used to describe the process of snow and ice changing into water, vapor in the air, without first melting into water, from solid to gas without going first into liquid. Evaporation. Evaporation is a type of vaporization that occurs on the surface of a liquid as it changes into gas phase. High concentration of the evaporating substance in the surrounding gas significantly slow down evaporation, such as when humidity affects rate of evaporation of water from liquid to gas. Freezing. Freezing occurs when a liquid cools to a point at which its particles no longer have enough energy to overcome the force of attraction between them. Instead, the particles remain in fixed positions, crowded closely together. The freezing point of a substance is the temperature at which it freezes. Water freezes at a temperature of 0 degrees Celsius or lower, from liquid to solid. Condensation. Condensation is the process by which water vapor in the air is changed into liquid water. It's the opposite of evaporation. Condensation is crucial to the water cycle because it is responsible for the formation of clouds from gas to liquid. Lastly is the deposition. Removing heat energy from water vapor causes it to become a solid rather than liquid. Deposition occurs when water vapor changes state directly from a gas to a solid, or bursts of sublimation. Like for example, it occurs in high altitude places like in the top of a mountain, from gas to solid without going into liquid first.
So good day everyone. So today we're going to discuss another classification of water chemistry. So without further ado, let's proceed to the key aspect of water. Key aspect of water. So first, let's tackle what is pH level. So pH level basically, it is a measure how acid or basic solution is. So it is more scientific definition is that indicates the concentration of hydrogen ions in liquid, while a low pH indicate a higher concentration of hydrogen. A high pH indicates a lower hydrogen concentration. So basically that is the meaning of pH level. I know that you are heard what pH level. Sometimes you see it labeling in a water bottle. And the next one is alkalinity. Alkalinity, it is not a chemical in water, but more on it is a dependent on the presence of certain chemical in the water, such as the bicarbonates, carbonates, and hydroxides. And next one, we do have the hardness of the water. The hardness is a simple definition of water hardness that amounts dissolved minerals, largely calcium and magnesium. And you may felt effects of hard water literally the last time you wash your hands. And next one, we have here dissolved oxygen. Dissolved oxygen, it is needed by aquatic organism living in natural waters. The dissolved oxygen is bred by fish and zooplankton, and it's needed by them to survive. And the last one, we do have here the presence of nutrients, metal and other chemicals component. So this is, so for example, metal ions or salts containing metals dissolved in groundwater and surfaces water when the water comes into contact with rock soils containing metals, usually in form of metal salts. Metals can also enter in discharge form of sewage treatment, industrial plants, and other resources. And next one, we're going to proceed to the next discussion, which is why chemistry is important to really study. So, and here, water chemistry has a major influence on materials degradation, and it's necessary to understand those water properties that influence material degradation process, in particular for any supercritical water cooled reactor. So, water chemistry basically has a lot of things to be known, and it is so important when it comes to primary resources such as a plant, where we could be able to have an energy resources that we are using in our daily lives. And also water chemistry has something to do with corrosion, because it is water chemistry, it is the chemical reaction. So you guys have know what corrosion is. So corrosion is basically it is a natural process of converts refined metals into more chemically stable oxide. So corrosion occurs because of chemical reactions that happens when the water and metals are in contact, such as in pipe, rusted iron, and most well-known form of corrosion. So basically, guys, in addition with this one, the water chemistry has something to do with the chemical reactant, and that chemical reactant resulted as some or more of corrosion, and corrosion is something that you might be able to see inside of the pipeline, water pipeline. It is the thing that in there, and also our rusty metal is also a part of a corrosion. It also the results of a chemical reaction when water has something to be then connected into metal. So the next thing to be discussed is, yeah, by the help of studying water chemistry, it lighten up the water treatment plant design in its easiest way. Um, Water chemistry perhaps less exciting than the other energetic compounds because much equipment looks archaic. Archaic means it is very old-fashioned materials or equipment. And regarding this one, we do have here the five major unit process, include which is the chemical coagulation, flocculation, sedimentation, and disinfection and filtration. So here I'm going to provide again the overview for this one, guys. So um, chemical encapsulation, it is the process or treatment we use to remove the solid waste or solid thing part from the water. Basically, it is a process where the chlorine is added into the water to be dissolved the solid particle or the huge particle that you might be able to see in your naked eye in the water. So the next one is the flocculation. The flocculation is the water treatment process solids from larger cluster or flux. Alright, so flocculation is a common method of stormwater treatment and wastewater treatment and in purification of drinking water. So basically, flocculation, it is the water that has contaminated. I think that has been flocculate to use as a drinking water for us. And the next one is sedimentation. Sedimentation is a process relies on the use of sedimentation tanks that remove larger solids subsequent to it more likely coagulation that removes the huge particle of the water and subsequently treatment process by may be used after sedimentation processes tanks. And the next one is disinfection and filtration. I would like to inform you that the difference between the disinfection is to prevent contamination with germs, water. On the other hand, filtration is the process of removing, or reducing concentration or of particulate matter, including suspended particles. The last part to discuss is the factors that affects negatively the water chemistry. In other words, this is a toxic water pollutants that cannot be drunk or used for essential purposes. Like water pollutants include bacteria, viruses, parasites, fertilizer, pesticide, pharmaceutical products, nitrate, phosphate. So those are the main water pollutants that we do have here in our various water pollutants has been made by human. So here is it is sometimes caused by nature, yes, and such as when mercury filters from Earth's crust, polluting oceans, river lakes, canals, and reservoirs. However, the most common cause for quality water is a human activity, and that's why we are facing these consequences as of today. And we will now go on to explain those consequences. So the first thing to be discussed, the consequences is the global warming. We all know aware about the global warming, how big issue it is, and we are facing it right now. Global warming is a high temperature caused by CO2 emission heat the water, reducing the oxygen content. So global warming is the highly issue that we are facing every day in our daily life. When we go outside, um, you're going to feel directly the heat rays of the sunlight. The next one is the deforestation. Filling forests can exhaust water resources and generate organic residue, which becomes a breeding ground for harmful bacteria. When we are not able to maintain our forest and still doing the deforestation, maybe there are a lot of bacteria and fungi will be going to be live in some particular um, area in our forest because there is no trees to be eaten by the other prior of living organisms. So the next one is industry, agricultural, livestock farming, chemical dumping from these sectors is one of the main cause of eutrophication of water. The dumping of chemicals in the water is one of the greatest pollutants that we must avoid or prevent. And in line with that, the rubbish and fecal water dumping, also that one, the throwing of garbage in the water and some other polymer materials. And maritime traffic, much of plastic pollution in the ocean comes from the fishing boats, tankers and cargo. And the last one, pollutants are toxic things that caused by humans is the fuel spillage. The transportation and storage of oil and its derivative is subject to leakage to the pollutes of water resources. So, fuel spillage is among those things that affects and pollutes water and affects the living organism under and beneath the oceans, such as our fishes and other living organisms greatly affected by this fuel spillage. And in conclusion, water is vital for all life. Its versatility and adaptability help perform important chemical reactors. Its simple molecular structure helps maintain important shapes for cells, inner components in outer membrane, and no other molecule matches water when it comes to unique properties that supports life. That is accurate. Excitingly, researchers continue to establish new properties of water, such as additional effects of its asymmetrical structure. Scientists have yet to determine physiological impacts of these properties, and it's amazing how a simple molecule in universally important organism with diversity. So, guys, basically, water is so important when it comes to uh, living organisms such as human being. And I hope you guys learned something on our report. Thank you so much for listening on what our group reported to you. I hope you gained something. I hope you valued the simple molecular things that we do have, and that is the water. And I hope from now on you can be able to take some step for you to be able to save and not to pollute the water resources here in our world and also here in our life. Thank you so much for listening to our report, and this is the end of the video.